Ever since I made the first one of these little plasma flame circuits, thought they were really cool, and I wanted to make another one, and got pretty lucky with the tedious tuning on the first one, to where basically how that one works is I get a pretty good flame on it, which I can improve with the glass. But the particular tuning I ended up with by moving the leads around, changing the capacitance, trying different MOSFETs, changing out different coils. It seemed what I ended up with was to where I leave a certain voltage setting on the divider, and then from there I can just turn the input voltage up. And I haven't tried it higher than about 35 volts, but the input current seems to stabilize at like 2.5 amps. Pretty much stays there, from between like 15 volts all the way up to like 35 volts. I've got a pretty big heatsink on there, but that in conjunction with the fairly thick wire on the resonator, I'm able to run it for a pretty long time. The only problem with that is, it's much larger than I would have wanted it. I was seeing if I can replicate that, and that circuit's running about 16 megahertz with a 460. This one, because of Teslaundmehr's recent video with Jay from Plasma Channel, they just made some which are pretty awesome. I'm like, man, I really need to get one. So I tried to use Teslaundmehr's values in his schematic as sort of a baseline. I know I wouldn't have a capacitor, a pulse capacitor, suitable for the primary resonator, but I knew I had this variable cap and it's gigantic, but I figured I could tune it with that. But anyway, I found either way to be, handy for the tuning process with these. Another thing I noticed was originally I had another one of these little green terminals here, these little 2-pin terminals, and that was where I was going to try different capacitor values. And I first tried, that's all I really had was some ceramic caps, 2 kV ceramic caps. So I tried those, and while they worked, they didn't last very long. So when I finally replaced that with this varicap right here, that can handle the voltage. But I noticed that when he says you need 2 kilovolts minimum in his circuit, he's not lying, because the distance between those little terminals there through the piece of plastic was not enough, and it was burning through, and I had to remove that terminal using his primary coil value. Depending on the FET, this is a 460. I think I've got about 150 picofarad variation on here, but that was giving me anywhere between like 4 megahertz, and I think I've seen even up to like 20 megahertz at one point. That's sort of like a easier way to tune these, so you don't even need a scope. You can just use a multimeter, put it on, frequency, and cut it on, cut the gate voltage up till it starts oscillating, and then you can vary the capacitor value here to change the resonant frequency on this coil here. And I eventually ended up having it set to about 10 megahertz. I think it's like 9.8 right now. But so then basically what I did is I sort of just ballparked the secondary resonator here by sort of sticking close to his values. I mean, basically what I usually have been trying to do now is use as thick of a wire as I can, but where I can also fit, at the very least something like 80 turns on there. And I was able to get a much thicker coil that only had about 40 turns on it of this gauge, resonating pretty good. It's just the maximum flame size I can get out of it wasn't all that impressive. The higher in the frequency I ran this LC circuit on the primary here, it seemed like the more impressive I could get as far as just trying to run loads off that by itself without adding the secondary. Lights would get brighter, I could pull hotter arcs off this high voltage leg right here on this side. It's sort of like a sacrifice there, where I started thinking to myself, like, man, maybe I should try to run like a 20 megahertz secondary coil. But the whole problem there is obviously I got a 460 on here, and heat is a big issue with the high on resistance. But again, I find these to be more resilient, seems like. I don't always buy legit transistors. They're pretty much these usually come from Amazon or eBay. But the 260s I had, they didn't last me long at all. They popped very quickly with testing and variation. The 460s, have seemed to survive. I haven't popped any, this is the only one that's been on this circuit so far messing with it. Basically all I did was I added way more turns than I knew would be necessary for this coil right here at the intended frequency. And recently I've just been ever slowly backing the frequency up by removing turns on here. So when I do that, like say for example, I originally had this running closer to 9 megahertz, and I wasn't quite happy with the output. I wanted to get the frequency a little higher, so I removed, I don't know, it's probably like 20 turns or something, and now it's running closer to 9.8 megahertz, and I'm just sort of seeing what the output looks like by incrementally removing those turns, increasing the frequency, and then every time I do that, I have to adjust my capacitor value over here to get this coil resonating. So it's like I might pull off too many turns and go too far, you know what I mean? Or I might reach a point where I might think, all right, cool. But I do remember thinking, I like the feel that this thing is putting out over 12 megahertz. The problem there is by the time I reach 12 megahertz with this coil, I would have pulled off a significant amount of wire. So all these variables, you know what I mean? But yeah, that was sort of like my basic tuning process without using a scope. Go the old circuit style, use the variable cap, and then once you find your desired settings, then you take whatever this value is and you replace that with a suitable pulse capacitor of the same value, or very, very similar. Thing about using 460s, which I try to do just out of, I guess, practicality, I guess you could say. They're inexpensive when you get them off eBay and such. And by the way, they're all come in different little flavors. This one, like you can't see it, this one's labeled 417L. If I was to replace that with a different 460, that even say came out of the same package, from an eBay vendor or something, it might have slightly different, binning on there or whatever their process is, then I might see a whole different type of circuit operation when I start adjusting these values to where, it might cut out at a certain capacitance setting, and then the only way I get it oscillating again is if I increase the gate voltage. You might have a FET like this one where that's not the case. I can do a clean sweep all the way down, and all it does is just change the frequency. It becomes a rather robust high frequency oscillator at that point. Or you might have another 460 that you put on there that yet again has slightly different values, and it acts completely different, where you can't even tune it to get the same output that you had, and even when it's running, it's just pulling significantly more current, something like that. So in this case, I've noticed that when I start trying to get a flame and push it to much higher power out of it, to the point where I need to push in excess of 4 amps, in the 30-40 volt range, that's where a heatsink of this size starts to just not cut it. It cannot wick away the heat quicker than the MOSFET is generating it in the switching. Even with a fan on there like this that I might have going full speed or something, it might not even, something like that right there will run fine until I get up into 3.5 or 4 amps. Then it's just not able to keep up, and what you might gradually see is a breakdown in the MOSFET that is just going to be a little slower because you've got this active cooling on it, but it's still going to break down over time. And that's the only way I've seen these 460s pop so far. I haven't really had problems with the gates on them, but I do have a couple 15 volt zeners. So this is basically like Teslaundmehr's schematic, except this is just a 500 volt, it's like 85 microfarad, something like that. Got 4.7 nanofarad on there still. I tried to bump that down to about 2.2 with this 460, and it really didn't make a whole lot of difference that I could tell without looking at it through a scope. My little RFC coil down there, couple strands of wire in parallel there. Got about 6 turns or so. About 5.5, just like Teslaundmehr. Ballpark values, basically. So it's at 20 volts right now. Got to crank the gate up a little bit. Boom. So see at 20 volts, the way I've got it tuned right now, it's already pulling about a little over 3 amps. So that means if I try to crank this up to 30, then it might overheat a little bit. But what I usually do is I'll crank the gate back down a little bit, so you can see now we're pulling a little under 3 amps, to the point where the flame does not considerably diminish. And now, since it is a 460, cut the voltage back up. So I'm just going to go ahead and bring it to 30. So now we're sort of, we're about on 100 watts now. I pulled this little bulb out from over my stove because it had burned out, and I figured, hey, I'll use that. And man, as soon as I put it up next to it, it cracked it immediately. So anyway, that's gone. But yeah, that primary LC right there on this high side right here is it is putting out. That's a hot arc. Now it's busting out. Started busting out the side instead of the top. Yeah, you saw, that's a hot arc. It's heating that up pretty good. That's one of them. Dang, I shouldn't do that. It bent my little whoop. Wire jumped out and lit the cardboard on fire. You can see what I'm doing here is I was incrementally pulling turns off the top of this coil, and then I didn't remove the cardboard with it, and that was a no-no. So I had the top of the wire just chasing along the side of the cardboard, and then, well, you see what happened there. So here's going with a little bit of glass on the breakout point, and this one I've got the gate voltage basically set right on the edge of where it starts oscillating, so I haven't backed it back down, and this is about as high as I'd want to turn it. I mean, I could turn it up a little bit higher, but any more I crank it, it starts to get dangerous, in the danger zone where I might pop that FET. So I'd rather just leave it right there. But I also wouldn't want to crank the voltage up, much higher than say 30 or so, unless I up the heat sink. I don't really know how that's switching, but see how that works. And that one's going at about 9.9 megahertz at the moment. So like I say, I might continually pull turns off that to try to get it going closer to maybe 12 or higher. So about, at a solid 100 watts or so at the 30 volt region there. And I'd say that's about at the point where really any more than that, I feel like it's dangerous, even with that fan going for that heat sink. And I would guess, let's say if I put it to 35 volts, I would imagine I would see that current draw increase steadily over time till it just reached a point where, suddenly it'll just break down and die from overheating. So this is still relatively stable. But again, let me cut the gate voltage down a little bit here. So I haven't brought the size of the flame down too considerably, but you can see I've brought it down to where a little under 80 watts. So now I'll feel more comfortable cranking this voltage up. I think the Oh, that's right. I had cut out because I had turned the pot down. I keep forgetting that. So that's the problem there when you're doing that. If I cut the pot back down, I can't cut it down too much because then eventually the circuit might go out of oscillation. We'll see if it goes back out again. 35 volts. I'll just leave that about 35 volts. So, now again, once again, I'm about roughly the 100-watt region, but I'm able to get away with it with a little bit less current because I'm just raising the voltage, obviously. And that's with it. Of course, see, now it might go out when I try to load it down too much, like this right here. Yeah, see it. So it just went out, pulling too much, and I wouldn't want to try to pull full load. See, a lot of times what you might see is, I guess, someone holding something right at the breakout point like this, trying to pull it out immediately while cranking the knob. That's what, Teslaundmehr was doing in his video. It's probably because if it's not breaking out, it's pulling a lot of power. So you want that breakout to come sort of immediately. So right there, before it broke out, I heard a little popping going on in the capacitor there. But since it is set to where the gate voltage is right about where it needs to be to kickstart, it's going to reliably start every time, no matter how much I disturb this output here like I'm doing. So I guess that's just how it goes. I could reliably back the pot down very slightly, I suppose, which might be what I do right here, to where, let's just say I bring it down to just very slightly like that, and then settle for a voltage of, I don't know, let's see where it goes to at 35. That's about 35 volts, 3 amps, about 110 watts or so. So something like that, I think that's not bad. That's probably a pretty good deal. You don't need a crazy huge heat sink, get a little fan going like that. Maybe, obviously, that cap is too big, needs to be replaced. I don't have one to replace it with, but it's about 10 megahertz or so there, pulling a little over 100 watts, and get a decent flame that you can run for a while with that gauge of resonator wire, which is cool because I noticed a lot of these ones that you can buy are so small, and plus you're not supposed to run them for longer than like a minute. That's no fun. But theoretically, I'd be able to push this closer to 200 watts if I wanted to, but just keep raising the voltage here. So that's 40. Get a little more ferocious there, but again, might want to have a slightly larger heatsink there for that. Yeah, when I cut the lights down, though, you can see how bright that glass starts glowing there. Pump it back up to about 40. So yeah, I'd say little under 150 watts is a pretty good deal with these. I've seen them. I swear I've seen them much more efficient. I don't know how they're doing it, but about 150 watts is not bad. Yeah, that thing's too bright. We can't see it. And the only thing about this coil is, you can see the closer I move my hand, the more it brings it out of tune there. It's the only downside. But yeah, pretty nifty. What I might end up doing is keep removing turns, maybe get that a little higher, but so running it like that for a little while, this heatsink is pretty hot, so yeah, it might not be wise to increase that frequency a whole lot more, and maybe just stick with that output, which isn't bad. And the only thing would be to replace this capacitor with the same value that it's at, basically.